Hello everyone, today we'll be starting on the applications of integration, first with definite integrals. Now a definite integral looks something like this, with a lower bound over here, a, and an upper bound over here, b. Now a definite integral from a to b of fx will give you the area under the curve from x equals to a to x equals to b. To compute the definite integral, this would just be substituting b into the result of the integral and then minus the substitution of a in the result of the integral. Usually, I'll write the result of the integral as big F of x. So I can say that the definite integral from a to b of fx will just be big F of b minus big F of a. Let's try out this question over here. Find the definite integral of x squared from 1 to 2. Now our first step is always to do the integration. So after you integrate x squared, you get x cubed over 3. And then I'll just write 2, 1 here. This means that I'm using 2 as my upper bound and using 1 as my lower bound. So let's utilize this over here. We will substitute 2 in first. So we get 2 cubed over 3 minus 1 cubed over 3. And this is just equals to 7 over 3. Over here, you realize that we don't need to have the plus c for definite integrals because actually the plus c will just cancel out. The GDC can also help us to compute definite integrals. Come over here to this button and then press this integral sign. Now earlier we had the integral from 1 to 2 of x squared. So we'll key in 1 as our lower bound and 2 as our upper bound. Then we have x squared and don't forget dx. And now we just press enter and here it gives us the answer. Remember, the GDC only gives you answers in decimal place, so it can't give you an exact form fraction. Now before we go on to the rest of the questions, let's look at some properties of definite integrals. Now if you look here, the definite integral from a to b of fx plus the definite integral from b to c of fx will just be equals to the definite integral from a to c. And why is this so? Finding this area over here, the area from a to b, and then finding this area over here, from b to c, will just be equals to the entire area from a to c. Another property is that the definite integral of fx from a to b is actually the negative of the definite integral from b to a of fx. This is because this over here will just become fa minus fb. And if we take the negative sign, this is just equals to fb minus fa, which is your original thing over here. This property also reminds you that you need to write your lower and upper bound properly. You cannot just randomly switch them. Now let's see how to find the definite integral when we have substitution and when we have integration by parts. So over here, we recognize that the substitution will just be u equals to ln x. Because if you take u equals to ln x, du will be equals to 1 over x dx. And we have the 1 over x dx right here. If we replace this all away, the ln x becomes u, and the 1 over x dx just becomes du. So this becomes the integral of u du. Now, we also have to change the bounds over here. This is because these are the bounds when you're integrating in terms of x, but we need to find the bounds when we're integrating in terms of u. So to find the new bounds, since we have u equals to ln x, we'll substitute in x equals to 1 and x equals to e. So when x equals to 1, we'll have ln 1, u equals to ln 1. So the lower bound now becomes ln 1, or just 0. And for the upper bound, we have e. So we substitute x for e over here, and we'll get u equals to ln e. Ln e is just 1, so now we know that our new upper bound will just be 1. After integrating, we'll get u squared over 2 with bounds 1, 0. And if we substitute this in, this becomes 1 squared over 2 minus 0 squared over 2, which is just half. If you realize, we're not really replacing the u back with x because we're already substituting the bounds in terms of u. Finally, we're going to look at how to apply definite integrals for integration by parts. So first, by Lie8, I'm going to choose u equals to ln x and v prime equals to x. This means that u prime will just be 1 over x, and v will be x squared over 2. Now to find this integral, I'm going to take uv minus the integral of u prime times v. So u times v is just half x squared ln x. Now take minus the integral of 1 over x times x squared over 2. So that's just x over 2. Now don't forget your bounds. I have the lower bound as 1 and the upper bound as e. And over here, I just straight away substitute my bounds 1 and e. So this first part just becomes e squared over 2 ln e, which is just 1. And then we have the integral of x over 2, which is just x squared over 4. And then we have the upper bound of e and the lower bound of 1. Let's do the substitution again. So this becomes e squared over 4 minus 1/4. And after simplifying, I should get e squared over 4 plus 1/4. And that's all for definite integrals. Thank you so much for watching. Our next video will be an area under a curve.